Hi, I'm Shay, and this is Mike. We made a weather clock. Basically, what it is this station right here tells the time on Nixie tubes, which are basically neon-filled tubes that excite the neon inside using a cathode and an anode to display the values. The colored light that you see is our temperature reader, which comes from a sensor that's over here in this box. The two are communicating wirelessly over radio frequencies. And so over here we have a temperature sensor, a sunlight reader, a wind gauge, and also a rain gauge. So every time each one of these is stimulated, it tells an LED over here to react. Right now in this room, it thinks that it's cloudy outside, so this indicator up here shows that it's cloudy. And if we take some sunlight and put it on over here, the light will turn off. So basically this way, if you just look over at your clock, you'll see that, it's relatively warm out and it's cloudy out. The other two sensors are for rain, so you want to demonstrate the rain? Basically, the rain funnels into this, which has a bucket inside that will tip every time a certain amount of rain comes in. So as he pours it, it registers that it's raining, and then over here, it lights up the bottom right one. It also lit up the top left one because it registered that there is a lot of rain. Our top left light bulb shows that it's just terrible outside and just don't go outside. Our wind sensor, as the wind comes in, it counts how many revolutions it's taking in and calculates how much wind. And then in the bottom left, once it knows that it hits 10 miles an hour, it will light up. Whereas if the wind hits 23 miles an hour, which is what a tropical depression is, the bad weather sensor in the upper left will initiate again. We developed the clock itself, which is we set it in the very beginning, and then it uses a piezo crystal, which vibrates at a certain frequency, so we know it can count the time, keep the time going. Over here, we put some ice on our temperature gauge, and so that's why it was reading blue. And then we took off the ice, and it changes to a magenta. And if we heat it up even more, we use 6 different colors throughout the spectrum of 0 to 100 degrees Celsius. So it goes blue, turquoise, green, magenta, yellow, and red. So red is the hottest.